There is a rule that almost everyone learns early when it comes to comets. When a comet approaches the sun, its tail always points away. Not sometimes, not usually, always. Solar radiation pressure and the solar wind push dust and gas outward, carving a glowing plume that streams in the opposite direction of the sun like a weather vane locked in place by physics. That is why what astronomers are seeing now with 3I Atlas feels so unsettling, not dramatic, just wrong in a quiet, technical way. Instead of forming a clean tail that stretches away from the sun, this object is producing a distinct dust structure that points toward it, not briefly, not faintly, but clearly enough that multiple observing teams flagged the same feature independently. This is not a rumor fueled by social media screenshots or a single ambiguous image taken at a bad angle. The sunward dust feature has been captured across different nights, by different instruments, and from different vantage points. Each time, the geometry changes slightly. And each time, the same contradiction remains. Comets are not supposed to do this. Dust is not supposed to survive there, and light pressure is not supposed to lose. At this stage, astronomers are not arguing about whether the images are real. That question has already been answered. What they are grappling with now is far more uncomfortable because if the observations are correct, then something about the way this dust is behaving does not match the simplest rules we rely on to understand comet physics. Which means the problem isn't the picture, it's the physics. The first reaction most people have to a sunward tail is simple dismissal. It must be a camera trick, a projection effect, a coincidence of perspective where dust is actually trailing behind the object, but from Earth, it looks like it is pointing toward the Sunday. And to be fair, that explanation has worked before. Comet anti-tails are a known phenomenon. Under very specific viewing angles, heavier dust particles can lag behind the comet's orbit and briefly line up in a way that creates the illusion of a tail pointing sunward. Astronomers are familiar with this. They are cautious because of it. But that explanation starts to collapse when the geometry changes and the feature does not. With 3I Atlas, the sunward dust structure has been observed by multiple telescopes on different nights from different locations relative to the Sunday. As the object's position shifts, the viewing angle shifts with it. Yet the dust feature remains oriented in the same physically impossible direction. That is the key difference. Perspective effects vanish when geometry changes. Real structures do not. This is why astronomers are now treating the anti-tail on 3I Atlas as a physical dust feature, not a visual artifact. The dust is genuinely present in a region where solar radiation pressure should be clearing it out, not allowing it to persist. Once that conclusion is reached, the conversation changes completely. Because the moment the structure is accepted as real, there is no optical illusion left to blame. So, if it's real, the next question becomes unavoidable. To understand why this matters, you have to strip comet physics down to its simplest rules. Not theory, not speculation, just fundamentals. Every comet in the solar system is governed by two dominant forces once it gets close to the Sunday. The first is solar radiation pressure. Sunlight itself carries momentum, and when it hits tiny dust particles, it physically pushes them outward. It is weak on large objects, but incredibly effective on fine dust. That is why comet tails always stretch away from the sun, no matter which direction the comet is traveling. The second force is the solar wind, a continuous stream of charged particles flowing outward at hundreds of kilometers per second. It acts like a cosmic current, sweeping gas and dust away from the sun even more aggressively. Between radiation pressure and the solar wind, the rules are clear. Loose material does not linger on the sun-facing side. It gets cleared out fast. This is why comet behavior is usually predictable. Ice heats up, gas escapes, dust is dragged outward, and tails form in the anti-solar direction. Even when comets fragment or behave erratically, the direction of dust motion still obeys those forces. Nature allows chaos, but not rebellion against momentum. That is what makes 3I Atlas so uncomfortable. The dust structure pointing toward the sun is not just faint or fleeting. It is coherent, persistent, and visible across changing geometry. Which means the dust is either unusually large, unusually dense, or responding to forces we do not normally associate with cometary material. Because under standard physics, dust should not survive there at all, unless the dust isn't behaving the way we expect. Astronomers have documented them before, and that is important to say out loud. This is not an unknown category of behavior, but it is a rare one, and it comes with very specific conditions. In normal cases, an anti-tail forms when a comet releases unusually large, slow-moving dust grains. These particles do not get pushed away as quickly by sunlight. When Earth happens to line up just right with the comet's orbital plane, those heavier grains can appear to form a tail pointing toward the sunday. It is a trick of geometry layered on top of sluggish dust dynamics. Change the viewing angle, and the illusion disappears. That framework is well understood. It has been observed, modeled, and reproduced in simulations. And that is exactly why 3I Atlas is uncomfortable to classify. Because this time, the geometry does not resolve the structure. The sunward feature persists across different observing positions. It does not fade when angles shift. And its definition is sharper than expected for slow, dispersed grains drifting along an orbital plane. The structure looks organized, not smeared. Sustained, not fleeting. Even more problematic, the implied dust properties do not line up cleanly. To resist solar pressure this effectively, the grains would need to be significantly larger than typical comet dust. But material that large should fall behind the comet, not maintain a coherent sunward extension over time. The balance does not close. So, while anti-tails exist, 3I Atlas does not sit comfortably inside the known examples. It follows some of the rules, but not all of them. And that mismatch is where the unease begins. This is the moment where restraint matters. Despite the headlines and the speculation spiraling online, no one tracking 3I Atlas is claiming intent, intelligence, or danger. That point needs to be made clearly. The concern here is not fear. It is fit. The observations are not sitting comfortably inside the models astronomers rely on to describe how comet dust should behave. At its core, the problem is mechanical, not dramatic. Dust grains released from a comet follow predictable rules. Their motion depends on size, mass, electrical charge, and how strongly solar radiation and the solar wind can push them. When those parameters are fed into simulations, the outcome is usually clear. Dust goes one way, gas goes another. Structures spread, fade, and dissolve. But with 3I Atlas, the dust dynamics are stubborn. The sunward feature does not disperse as expected, it does not collapse into noise, and it does not respond cleanly to changes in geometry or solar angle. That forces researchers to consider quieter possibilities, not extraordinary ones, but inconvenient ones. Perhaps the particles are larger than assumed. Perhaps their composition is unusual, making them less responsive to radiation pressure. Perhaps the dust is being released in a narrow time window or from a constrained region on the surface, creating structure where randomness should dominate. Each option is plausible on its own. None of them are comfortable. This is why the language from scientists remains careful. When models stop lining up, you do not leap to conclusions. You slow down. You recheck assumptions. And you watch more closely, because when models stop lining up, attention sharpens. This is why NASA is watching closely, not urgently, not fearfully, but carefully. When agencies use words like alert, they are not signaling danger. They are signaling focus, increased monitoring, more frequent modeling updates, more eyes on the data as it arrives. This is procedure, not panic. Interstellar objects already receive extra scrutiny by default. They are outsiders to our solar system, formed under conditions we cannot easily replicate or fully reconstruct. Their chemistry, structure, and long-term evolution carry signatures from environments far beyond our own. That alone earns attention. But attention deepens when behavior deviates more than once. What matters here is not the anti-tail by itself. It is not even how rare that feature is. What matters is repetition. Multiple deviations, observed independently, persisting across time and geometry. A dust structure that refuses to dissolve as expected. Behavior that does not collapse back into noise when viewing angles change. Each anomaly on its own might be tolerable. Stacked together, they justify closer watch. NASA's role at this stage is not to explain everything immediately. It is to track, compare, and wait. to see whether the behavior resolves naturally as conditions evolve or whether it continues to diverge from prediction. That distinction takes time, patience, and restraint. Because in science, concern does not come from a single surprise. It comes from patterns that keep returning. And with 3I, Atlas, the pattern has not finished forming yet. And this may not be the last deviation. So what does this actually mean? Not that 3I, Atlas is defying physics, but that it is exposing where our physics is still incomplete. Every model astronomers use is built on assumptions drawn from solar system comets, objects born here, aged here, shaped by the same environment for billions of years. 3I, Atlas, is different. It carries a history we did not witness. The sunward dust feature is not a threat. It is not a message. It is not intent. It is a diagnostic clue, a sign that the material properties, grain sizes, or release dynamics of this object do not align neatly with the cases we know best. That is how science advances, not through certainty, but through friction between expectation and observation. Interstellar objects are valuable precisely because they break our habits of thought. They force us to ask whether our rules are universal or merely local. Whether what we call normal comet behavior is actually a narrow subset shaped by our own neighborhood of space. In that sense, the antitail is not pointing toward the sun at all. It is pointing inward toward the limits of our models, our assumptions, and our experience, toward questions we have not yet learned how to ask cleanly. 3I. Atlas isn't pointing at the sun, it's pointing at what we still don't understand.